This is a CCEA Maths paper. This one is the M8 paper 1, so it's the non-calculator part of the M8 paper, and it's from Monday the 13th of June 2022, so it's a summer 22 paper. Let's take a wee look at question 1 then. Reflect triangle A in the line x equals 1. Now people get confused about this. The line x equals 1 is the line where all the x coordinates are 1. So for example, 1, 0, 1, 2, 1, minus 3. So it's this vertical line here. What confuses people is because the y-axis is a vertical line, they think the line x equals 1 should be a horizontal line. So that's my line then, x equals 1. So this one is 2 squares away. So we go to the other side. So we're putting a point there. This one's 3 squares away. 1, 2, 3. 1, 2, 3. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's it reflected. Question 2. What is the main difference between the binary number system and the decimal number system? Sometimes it can be quite hard to put into words, but I guess it's because it's base 2 rather than base 10. Now that sounds a bit kind of grandiose. You might just want to say binary uses only 2 symbols. And we know then is 0 and 1, whereas decimal then uses more than that. Write the binary number 111111 as a decimal number. So we start with our power of 2, so 2 to the power of 0 is 1, then we have 2, 4, 8, 16 and 32. So it's 1, 1, 1, 1, 1, 1, 32 and 16 and 8 gives me 56, that gives me 60, 61, 62 and 63. Some people know that if they are all ones, it's just one fewer than the next one, which would be 64, take away 1 and 63. That's okay. We're going to do something similar then for the next part here. We're going to set up our 1, 2, 4, 8, 16, 32, and we'll need then a 64 then as well. So we're trying to make a number 87. We'll start with the biggest. It can have a 64 in it. It can't have a 32. That would take us up to 96. So that's no good. 64 and 16 is 80. So we can have one of those. Can't have an 8. Can't have a 4, so we're in 84, 85, 86, 87. So our answer is 1010111. Question 3, simplify w cubed times w squared. That's w to the power of 5. Y to the power of 6 over y to the power of 2. We subtract the powers there, so we get y to the power of 4. Nth term of this sequence, number them 1, 2, 3, 4 and 5. Our gap is 7 each time. That means it's 7n. Quite often you need to then add or subtract something, but in this one we don't, so it's just 7n. 5 to the power minus 2. The 2 does what it always does. 5 squared is 25, and the minus means it's 1 over. So my answer to that then is 1 over 25. 1 to the power 5 is 1. 6 to the power 0 is 1, so anything to the power 0 gives me 1, and 1 plus 1 is of course 2. The following table gives some values for the quadratic equation x squared minus 3x plus 1. On the grid below, draw the graph of x squared minus 3x plus 1 for values of x between minus 2 and 4. So we want to plot the point minus 2, 11 to start with. So minus 2, 11. The next point then is minus 1, 5. 0, 1. 1, minus 1. You can just about see it. 2, minus 1. 3, 1. And then 4, 5. And again, just the best curve you can manage to do. Remember, you can turn your page round. You don't have to be kind of facing all the way. So I'm going to try and join this together as best as I can. Nice neat curve. And so we have something like that. It's not great, but it's smooth enough, I think. Use your graph to estimate the values of x for which y is 3. So let's go back then to our graph. When y is 3, we have this wee line going across here. Now you don't need to do the line in, you just need to kind of circle these. So it's here, and it's here, and we're trying to find in those x coordinates. So that's minus 0.6, and that then is 3.6. So those are the two solutions we need. Minus 0.6 and 3.6. Toby walks his dog in the field ABCD, so it is always more than 40 metres from A, nearer to A than B, and nearer to DA than DC. Shade the area where Toby walks his dog. So let's take a wee look then. So first of all, 40 metres from A, and our scale that we're doing then is 1 centimetre to 10 metres. So I want to set this up then as 4 centimetres. So I need my compass, and you can see hopefully my hands get out of the way, that that's me set up then on 4 centimetres. So with my 4 centimetres then, I'm gonna, it's easier if I spin it around. So I have that bit, so it's more than 40 metres, which means it's to be outside the bit then that we need to shade. Nearer to A than B, so here's A and here's B, so I need to do then the perpendicular bisector of that. So I go more than halfway, I do my line here, I go back then to the other side, again I'm going to flip it upside down. And then I join those lines up. So anything on this side of the line then is nearer to A than B, and then nearer to DA than to DC. So there's that and there's that, so I need to do the I need to bisect that angle there. So if I set my compass to do there and there, I then go to each of those points and draw a line here, go to this point and mark it off there, and there's my wee marker that I need to draw in. So one here, and then going through the point D. See there where Toby walks his dog, so more than 40 metres from A, can't be in this, so it's all out of this. Nearer to A than B on this side, and nearer to DA, DC, so it's going to be this area here. That's the bit there then that we need to shade. A tent in the shape of a cone has a perpendicular height of 7 metres and a volume of 220 metres cubed. Using pi equals 22/7, work out the base radius of this tent. Write your answer in Surd form. So our volume, if you look again at the formula sheet, is 1/3 pi r squared h. So that means we have 220 equals 1/3 times, they've told us to use 22/7, times r squared times by 7. And we then can do a wee bit of cancelling. So that 7 cancels with that one. And we can divide both sides here by 22. I'm just going to write it out before I do that. 200 is equal to 22/3 multiplied by r squared. Both of those very clearly divide by 22. That gives me 10 is 1/3 r squared. That means r squared is 30. So r then is going to be root 30. That doesn't cancel down any further. So we can put our answer into there. Question 7. Work out the value of m over n, giving your answer in standard form. So we need to divide these. So we're going to do 4.5 times 10 to the 7 divided by 5 times 10 to the minus 3. So doing the number bits, 4.5 divided by 5, we'll think about that in a wee second, times 10 to the 7 divided by 10 to the minus 3. 4.5 divided by 5 is tough enough. So 4.45 divided by 5 is 9. So 4.5 divided by 5 then is going to be 0.9 times 10. And we subtract our powers here. 10 to the 7 minus 3. So that gives me 10 to the 10. We're not quite there because this isn't in standard form. This number here isn't between 1 and 10. So we need to write this then in the standard form. So that's going to be 9 times 10 to the minus 1 multiplied by 10 to the 10. And that gives me then 9 times 10 to the 9 when we add those two numbers. Question 8, make q the subject of the formula. So we need to multiply through by r minus q first of all. That gives me p upon r minus q is q. Multiplying out my brackets, p r minus pq is q. Get the q's to one side. pr equals what I want, pq plus q. Factorize out the q. q upon p plus 1. And that means q then is pr over p plus 1. And that's our answer to that one. Here's a number with a value between 0 and 1 from a list below, which would have the lowest value. So if it's between 0 and 1, then this number here is going to be more than 1. This number here is going to be more than 1 as well, something to the minus 3, because it's going to be 1 over, and then if that's between 0 and 1 and you cube it, then it's going to be kind of small. So that's less than 1. This here is less than 1, and this one's less than 1, so just give me a wee minute. I think I've been talking pure nonsense there. So this number here is between 0 and 1. This number has to be bigger than 1. This number is bigger than 1 as well, because that's the same as 1 over x cubed. And if that number there is less than 1, whenever you cube it, it just gets smaller and smaller. So smaller number then kind of going into 1, we have that. And then if you have a number less than 1 and you find then the square root of it, it's actually going to make it bigger. And so my lowest value then for that one is going to be x. Which one is the biggest value? Well, that's less than 1, that's less than 1, so it's neither of those two. That's bigger than 1, but that one, the x cubed is a smaller number than the x. So the x cubed goes into 1 more times, so it's the x to the minus 3. 3 over 4 root 5 can be expressed in the form a root 5. Find the value of a. So we want to rationalize the denominator here. So we're going to 3 over 4 root 5, and we're going to times top and bottom then by root 5. That gives me 3 root 5 over 4 times 5, because root 5 times root 5 is 5, so it's going to be 20. If I rewrite then this is 3 over 20 root 5. So the number a that we're dealing with here then is 3 over 20. Scale model of a car is made. The length of the model is 1/10 of the length of the car. The volume of the petrol tank of the car is 50,000 cubic centimeters. What is the volume of the petrol tank of the model? So if the lengths are in the ratio 1 to 10, then the volumes must be in the ratio 1 to 10 cubed, which is 1 to 1,000. So you want to do then 50,000 divided by 1,000. And so the answer then to that is going to be 50. You need to be careful of that. It's not like it's a trick question, but because the lengths are in the ratio 1 to 10, then that means the volumes are in a ratio then to 1 to 1,000. Express the recurring decimal as a fraction in its simplest form. So I'm going to let x equal 0.26966969 go on forever. That means then what I want 100x is equal to 26.9696969. So whenever we subtract those, I get 99x is going to be 26.7. So that means x is 26.7 over 99, which is 267 over 990. And we need to try and think if this then divides by anything. So it looks like that means 270 would divide by 3, and that one divides by 3. So 270 divided by 3 would go 90 times. So that means it's then going to be 89. And dividing that by 3, then it's going to be 330. 89, as far as I know, is a prime number, so that's as far down as it's going to go. So it's 89 over 330. A circle of radius r has circumference c and area a. Circle whether each value is rational or irrational in the table. Radius and area. Okay, so in this case, whenever you go from the radius to the circumference, you're going to be multiplying by 2 pi, because it's 2 pi r. So if you do 2 pi times that, the pi's are going to cancel, so that one's going to be irrational. So you're going to be rational. Times in here, you're going to be timesing by pi r. So it's pi r squared effectively. So you're timesing it by itself and then timesing by pi. So you're going to have a pi then on the bottom, so that one's going to be irrational. Root 3 over pi, goodness. So if I multiply that by 2 pi, that's the same as root 3 over root pi. So if the square root of pi is irrational, so that one's then going to be irrational. That's quite a tough one. This one here, we need to square the r. So once we square that, we get 3 over pi, and then once you times that by pi, the pi disappears, so that one turns into irrational. And then 3 root pi, if you multiply that by 2 pi, you're going to get an irrational number. And if you multiply that by, so you square that, so 3, that's going to give you pi, and times by pi, and pi squared then is irrational as well. It's quite a tough one. Question 14, nearly there. A cuboid has sides of length this, this, and this. Find the length of the space diagonal given your answer in the form a root b. So we can kind of use, we're kind of 3D geometry here, and we can use we can square this, and square this, and that should then kind of give us our distance. So it's going to be d squared is equal to 3 plus 2 root 3 squared plus 3 plus root 3 squared plus 9 minus root 3 squared. So it's going to be tough enough. So my d squared, I'm going to write them out kind of nice and slowly here. So we have 3 plus 2 root 3 upon 3 plus 2 root 3 plus 3 plus root 3, 3 plus root 3 plus 9 minus root 3, 9 minus root 3. So let's do these. So we're going to have 9 plus 6 root 3 plus 6 root 3 plus that's 12 root 3. And then 2 root 3 times 2 root 3, that gives me 4 times 3, so that's going to be 12. Here is plus 9. 3 root 3 and 3 root 3 is going to be 6 root 3. And then root 3 times 3 is 3. And then 9 times 9 is 81. Minus 9 root 3 minus 9 root 3, so it's minus 18 root 3, and then minus root 3 times minus root 3 gives me 3. So this is 12 root 3 and 6 root 3 is 18 root 3 minus, so they actually all cancel each other out, and we're just in there with our numbers. So 9 plus 9 is 18, plus 12 gives me 30, 33, 36 and 81, then that all adds to 117. So d squared is 117 and d is equal to the square root of 117. Now 117 is kind of quite a tough one here because 117 is going to divide by 9, so it's root 13 times root 9, so that's going to be 3 root 13, which is quite a tricky one to finish with. So our answer is going to be 3 root 13. A bag contains X green and 5 red beads. 2 beads are taken without replacement from a bag at random. What is the probability of taking 2 green beads if X is 3? So if X is 3, that means we have 3 green and 5 red. So what's the probability of taking 2 green beads whenever they're not replaced? So it would be 3 over 8 multiplied by 2 over 7. So that's 3 over 28. What is the probability of taking 2 green beads if X has the larger value of 10? So if X then is 10, and then there's 5, so taking 2 green beads, so that we have then 10 green beads and we have 5 red beads. What's the probability of me taking a green? It would be 10 out of 15 multiplied by 9 over 14. Let's do a bit of cancelling here. That is a 5 and that's a 7. That is a 1 and that is a 3. That is a 1 and that is a 3. So that cancels down then to 3/7. Hence find the smallest value of X for which the probability of taking 2 green beads is greater than a half. So let's take a wee look. So we've tried it for 3 and it's quite small. We've tried it for 10 and it's still less than a half. So we're getting quite close, so because we just need to be a 3.5 there on our thing. So let's then kind of try for 11. So we have 11 green and 5 red. What would that be? That would be 11 over 16 multiplied by 10 and then 1 fewer over 15. What cancels there? The 10 over 15 cancels down and then into 2/3. That gives me an 8 and that gives me a 1, I think. So that's 11 over 24. So we're still less than a half. It would need to be 12 out of 24. So let's then kind of try for 12. 12 green and 5 red. So we've now got 17. So it's 12 over 17 multiplied by 11 over 16. What cancels there? Very little. As a 4 goes into those, so it would be a 3 and that would be a 4. 3 11s are 33 and 4 17s are 68. We're not quite there. We're getting very, very close. So that was 34. We would be there. So let's try for 13 green and 5 red. Don't want to get too much longer here. So 13 and 5 is 18. So it's 13 over 18 multiplied by 12 over 17. So they both cancel, give me a 3 and a 2. And that gives me then 26 over 51. And we're there. So my answer then, so that 13 is how many we need. And so we end up with that.